Section 2, Weather Basics, Digging Deeper, Air Masses and Weather, How and Why Air Rises. In the Investigate, you carried out investigations to explain the effects of different temperatures on a volume of air. You found that as air warms, it becomes less dense. Because it is less dense than its cooler surroundings, it rises. Warm air molecules have greater kinetic energy than the molecules in cold air. As the molecules move about with increasing speed, the spacing between individual molecules increases. As the spacing between molecules increases, the density of the air decreases. Air can also be forced to rise when it flows over mountains or collides with other air masses. An air mass is a huge volume of air in the lower atmosphere with similar temperature and moisture characteristics throughout. Four main mechanisms cause air to rise on a regional scale. Convective uplift. Convection refers to upward and downward motions of air caused by differences in air temperature. Differences in air temperature result in differences in air density. As the sun warms the ground warms the air immediately above it. Cooler, denser air from above sinks. It forces the warmer, less dense air at the ground to rise. The rising warm air expands and cools. Eventually, it sinks back to the ground, completing the convective circulation. Orographic uplift. Orographic refers to mountains. When the wind encounters a mountain range, it acts as a barrier. It forces the air upward. Frontal wedging. A front is a narrow zone of transition between different air masses. The air masses may be different in temperature and or humidity. When a cold air mass meets a warm air mass, the more dense cold air wedges or forces its way beneath the less dense warm air along a cold front. Convergence. Sometimes winds blowing from different directions meet head-to-head or converge. In this case, they have nowhere to go but up. Air masses. An air mass can cover thousands of square kilometers. It can be several kilometers thick. It gets its moisture and temperature characteristics from the area over which it forms. This is its source region. All of Earth's lower atmosphere can be split into areas dominated by particular air masses. Air masses are classified by their temperature and humidity as follows. Continental, relatively dry air masses that form over land. Maritime, relatively humid air masses that form over the ocean. Polar, cold air masses that form at high latitudes. Northern Canada, for example. Tropical, warm air masses that form at low latitudes. Gulf of Mexico, for example. Therefore, the general types of air masses include continental polar, continental tropical, maritime polar, maritime tropical, and Arctic air. The movement of air masses. An air mass may remain over its source region for days or weeks. However, it will eventually move into another region. Global winds are constantly redistributing Earth's thermal energy. An air mass moves in the direction in which it is pushed by a global wind belt. Warm air masses that form in lower latitudes move toward the poles. Cold air masses move toward the equator from source regions at high latitudes. Figure 1 shows the source regions for the air masses that regularly move over North America. As shown by the arrows, Cold air masses usually flow southeastward. Warm air masses flow northeastward. As air masses move out of their source region, they usually change. The change depends on the route they travel. For example, in winter, a cold air mass is warmed as it moves southeastward from its snow-covered source region to the bare ground of the southern United States. This is one of the main reasons why winter temperatures do not fall nearly as low in the southeastern states as they do in the Great Lakes region. What is a front? The kind of front that forms depends on the characteristics of the air masses and how they are moving. A cold front occurs when a cold air mass advances and meets a warm air mass. The moving cold air is more dense and pushes up the less dense warm air. If viewed from the side, a cold front would appear as a thin wedge of cold air advancing beneath warmer air. As the warm air rises, it cools. As the air cools, moisture begins to condense into tiny drops of water. If it is cold enough, the moisture condenses into tiny ice crystals. With enough humidity, clouds will form. Large clouds with vertical growth are common near a cold front. This is a result of the rapid uplift of warm air. These clouds can trigger brief, minutes to hours, but heavy rainfall and strong winds along the front. After the cold front passes, the weather is cold because the warm air is pushed away from the Earth's surface. A warm front occurs when a warm air mass advances and meets a cold air mass. The warm, less dense air rises over the cold, dense air. A warm front viewed from the side would appear as an even thinner wedge of cold air beneath a warmer air mass than in a cold front. The slope of a warm front is close to half as steep as that of a cold front. The smaller slope causes clouds and weather along a warm front to be spread over a larger area, to last a longer time, and to be less violent. Clouds that form are more stratified, with steady soaking rains that can last from several hours to a few days. After the front passes and the warm air gradually replaces the cold air, weather conditions are clear and warm. A stationary front occurs when cold and warm air masses meet, but neither one has enough force to move the other. Where the warm and cold air meet, water vapor in the form of air in the water vapor in the warm air may condense into rain, snow, fog, or clouds. As long as the front exists, clouds and precipitation will continue. However, stationary fronts seldom have extensive clouds and heavy precipitation. An occluded front forms when the faster moving cold front overtakes a slower moving warm front, causing the warm air mass to be completely lifted off the ground. The colder and denser air masses merge together underneath the less dense warm air mass. They push the warm air mass upward. The temperature near the ground becomes cooler as the warm air mass is cut off or occluded from the ground. As the warm air rises, it cools and its water vapor condenses. This creates clouds, rain, or snow. An occluded front usually moves very slowly and causes several days of cloudiness and light precipitation. Elements of weather. The observations you made in Part C of the Investigate included many of the most important elements of the weather. Recall that weather is defined as the atmospheric conditions at a particular time, day to day. One of the elements is air temperature. The temperature of air is the measure of the average motion of these molecules. Air temperature is measured with thermometers. Common thermometers consist of a liquid and glass tube attached to a scale marked in degrees Celsius or degrees Fahrenheit. As the liquid in the tube is heated, it expands and rises up in the tube. As the liquid in the tube is cooled, it moves downward in the tube. Air pressure is the force of the atmosphere above a given point. Air, or atmospheric pressure, is measured using a barometer. In the United States, it is ordinarily given in inches of mercury. As you discovered in Section 1, wind blows because air pressure is higher in one place than in another. Air moves from areas of high pressure to those of lower pressure. In addition, the greater the difference in air pressure from one place to another, the stronger the wind. Wind speed is measured with an anemometer. Most anemometers have horizontal shafts arranged like the spokes of a wheel. A cup is attached to the end of each shaft. The wind pushes the concave side of the cup up more than the convex side, so the anemometer spins in the wind. The stronger the wind, the faster the cups spin. The spin rate of the cups is calibrated in terms of wind speed. Wind direction is measured with a wind vane. Clouds are formed when humid air rises upward. As the air rises, it expands and becomes colder. With enough cooling, water vapor condenses into tiny water droplets or tiny ice crystals. You can see the droplets or crystals in the form of clouds. Clouds form at a wide range of altitudes. The appearance of clouds varies a great deal, depending on the movement of the air as the clouds are formed. Other things to observe about the clouds are the percentage of the sky they cover, where they are located in the sky, and the direction they move. Today, satellite photographs give meteorologists vital information about cloud cover and the directions clouds are moving. Raindrops form when droplets in clouds become large enough to fall out of the clouds. Rainfall is measured by the depth of water that falls on a level surface without soaking into the ground. Rain is usually measured with a rain gauge. Snow is measured with a ruler. Meteorologists use Doppler radar to track precipitation systems. Most online weather reports now include this information as part of the weather report. Relative humidity is a measure of the amount of water in the air. It is the ratio of amount of water a volume of air holds at a given temperature compared to how much water the volume of air could hold at the same temperature. Relative humidity is measured using a sling, psychrometer, or hygrometer. It is reported as a percentage. The movement of water between Earth's atmosphere, oceans, and land surface is known as the water cycle. There is one main loop in the water cycle. Due to the sun's energy, water evaporates at Earth's surface. It then moves as water vapor into the atmosphere. The water vapor loses heat, condenses into clouds, and falls from clouds as precipitation back to the Earth's surface. Water that falls onto the land can take various routes. Some water evaporates into the atmosphere. Some is temporarily stored in bodies of water. Some seeps into the ground. Ultimately, all water on land drains into the ocean.